For questions 4 and 5, I'm going to graph these on the calculator. So if you type 2 raised to the x plus 3, and you want to make sure that the plus 3 is on the main level, you don't want to have it in the exponent. And then if I graph this on the standard window, then it's going to look something like that. For number 5, this is 3 raised to the x plus 2, and you do want to make sure that the entire x plus 2 is in the exponent. So if you have the newer version of the calculator, it kind of looks like that. If you have the older version, you're going to need to type that. You want to make sure that the entire x plus 2 is in parentheses with the caret key here so that it knows that it's in the exponent. Okay, so if you graph that, then it looks like that. Okay, so there's some characteristics of exponential functions. And this really looks at this form here. So there's no adding a number in the exponent or adding a number on the main level. This is kind of going back to questions 2 and 3. And if the base b is greater than 1, then your graph is going to look like this. And there's really not much variety there. So if it's 4, or if it's 6, or if it's 2, as long as it's bigger than 1, it's basically going to just look like that. It may be a little bit steeper, but the shape is basically the same. So there's really not too much variety within exponential functions. Now, if your base is between 0 and 1, which really just means it's a decimal or a fraction, then the shape is going to be like this. And again, within that, there's not much variety. So if your base is 1/3, if your base is 1/2, if your base is 1/10, they basically all look the same. Some of them are a little bit steeper, but the shape is going to look like that. So the domain of exponential functions, this is really going all the way to the left and all the way to the right. So it's -infinity to infinity. The range, it never gets to 0, it never gets below 0. So it's going to be 0 to, and it will go up forever. So it goes to infinity. The horizontal asymptote, which is really just a fancy name for a boundary, and that is the x-axis. And really what that means is the x-axis serves as a boundary. So these functions are going to approach it and get close, but they're actually never going to reach it. And that's really why our range starts at 0, and it actually doesn't reach 0, because there's a boundary there. Okay, so finally, due to the rules of exponents, each graph will contain the points 0, 1, and that's because anything raised to the 0 power is 1. 1b, and that's because anything raised to the first power is itself. And -1 will be 1 over b, and that's because anything raised to the -1 power is the reciprocal.